Okay, we're back with our TL082 op-amp, which actually is a relatively high voltage, low noise, high bandwidth op-amp. And it's not optimized for low power supply, which we'll look at in a bit, but it will work with plus or minus 15 volts, which is what we have our device set at right now. So we have tracking set on the power supply, and it's 15 volts, so we're getting plus and minus 15 volt power supply and a ground. Now right now we've upped the input to 500 millivolts, so we're cranking about 10 times more voltage into the signal. I've turned the scope settings up, both the inputs, to 5 volts per division, which is quite a bit higher than they were before. And now I want to see what happens when I crank up my input signal. So I'm going to crank it up. I'm going to set it on the higher part of the setting, using these knob buttons here, and I'm going to start turning it up. And let's see what happens. So I've cranked up to 700 millivolts, which is really 1.4 volts peak to peak. It's saying 1.9 on the scope here for the input. My output is now at 13 volts. So I'm going up. My output's now at 18 volts. Going up. My output's now at 27 volts. Now I have plus or minus 15, which is 30 volts. Something's going to happen when I get near 30 volts. Oh my goodness, look at that. It stopped working. It's clipped out at 27 volts. This is called clipping. See, the output's clipped. And it's because we've run out of room on our power supply. If we were to raise our power supply voltage, and I believe this device, if we go look at its data sheet over here. Here's the data sheet. It should say what its absolute maximum power supply voltage is. Absolute maximum, plus or minus 18 volts. So we can go up to 18 on the supply voltage. So let's very carefully go up to 18. Hope it doesn't blow up. 16, 17, 18. And look, our signal's gone back. Right, we fixed it. We're now at 32 volts. If we crank up our input anymore though, we start clipping at the new power supply voltage. So it all has to do with how much power supply voltage we have. And I can just as easily turn my power supply voltage down. So I take it down. There's 10 volts. And we're almost getting a square wave out at this point. If I turn my input down, I can see that it's going down like this. Down here, let's go down, see how low we can go. Let's try plus or minus 5 volts. We're at 500 millivolts. Turn it down, I can get it to work. Let's crank up our scales over here now to 1 volt per division on each scale, since we've come down. So 5 volts we're still working okay, plus or minus 5. Let's go down to 2 volts. Here's 2 volts. Ooh, let's turn our signal down. And going down, down, down. We can get it to work again. Down at plus or minus 2 volt power supply. Now we can get some idea of here what our actual limits are. We're getting, if we crank up our input, it starts to fail. It looks like it's failing. It's failing on the negative supply first, and it's quite common that they're not symmetrical. And it's failing on the negative supply. We can switch our measurements to look at minimum on source 2. Gotta get in there quick before it minimum. And it says minus 0.68. Not very far down. Considering we have a negative 2 volt supply, we're only getting minus 0.68. So we've got basically 1.4 volts lost. We can't get down to on the negative side. Positive side is a little bit better. Let's crank up our input and see where it's clipping. And we'll have to switch to a different measurement now. Minimum, maximum. So the maximum is 1.35. So we're getting quite close to that positive supply of 2 volts. But our negative supply is really causing us some trouble. This is not a good thing, particularly if we wanted to use 0 and 5 volts as our power supply, which would be like plus or minus 2.5 in this case, if we wanted a 5 volt power supply, which is quite common. So this op amp has a maximum output swing of about 2 volts, and it won't get very close to the negative supply rail, which is going to be a problem if we want to use that negative supply rail as like ground, or if we want to operate close to that negative supply rail. So at this point we probably would like to swap to a different op amp and do some different things, and that will be a subject of another class, is single supply op amps.